Hi, good morning everyone. Today I will discuss some question of your exercise 12b, maxima and minima. Here is some question of finding the absolute maximum, absolute minimum value, and some questions of finding the local maxima and local minima of there, and some statement problem is also there. In your 12th B exercise, it's 7th part. Your question is fx is equal to x plus sine 2x and your intervals are 0 to 2 pi. You have to find here what is the absolute maximum value and what is the absolute minimum value here. First you will go with the differentiation of this. Differentiation of fx is f dash x is equal to 1 plus x differentiation is 1, sine differentiation is cos x. When you go with f dash x is equal to 0, that is 1 plus cos x is equal to 0, cos x is equal to minus 1. Cos x is equal to minus 1 will be on cos pi value. Cos pi value is minus 1. So that's why we write, instead of minus 1, we will write cos pi. Now x is equal to pi. Now we have already in our question our two intervals 0 to 2 pi and one interval between that is pi. Now x is equal to 0, pi and 2 pi. So we got the three values for finding the absolute maximum and absolute minimum value. These three values we put one by one in our original equation. Like in place of x, first we place 0. 0 plus sine 0 gives me 0. Pi value, instead of x, pi plus sine pi is equal to pi because sine pi value is 0. Similarly f2 pi, 2 pi plus sine 2 pi, sine 2 pi is 0 and my answer is 2 pi. According to that, if I observe these three values, our maximum value is 2 pi and here minimum value is 0. Minimum value is 0 at x is equal to 0 point and maximum value 2 pi is on x is equal to 2 pi. So minimum value 2 pi at x is equal to 2 pi and minimum value 0 at x is equal to 0. Now 12th question, 8th part. fx is equal to cos square x plus sin x. That is my next question of your 12th B exercise. Here our interval is 0 to pi. So it is differentiable for all x belongs to 0 pi. Now f dash x is equal to, first you have to differentiate with respect to x. So cos square x differentiation is 2 cos x minus sin x and sin x differentiation is cos x. You take cos x common, that will be 1 minus 2 sin x. Now our next step is, before going to the we not go to double differentiation because we have to find the absolute maximum, absolute minimum value. So f dash x is equal to 0, cos x 1 minus 2 sin x is equal to 0. Now we apply the zero product rule. Cos x is equal to 0, 1 minus 2 sin x is equal to 0. Cos x is equal to cos pi by 2, sin x is equal to 1 by 2, x is equal to pi by 2 and sin x is equal to sin pi by 6, that is 30 degree. Now here we got here also two values here, pi by 2, pi by 6, and also we have two intervals given in our question. So total values will be 0, pi by 6, pi by 2, but here before 180 degree there is one gain value of pi by 6, that is 5 pi by 6 because 0 to pi covers our two quadrants. Like here 0 to pi, two quadrants is there. So if there is, one is pi by 2, one is pi by 6, and before pi in the second quadrant that will be also 5 pi by 6. So we have 1, 2, 3, 4, 5 values. So 5 values one by one we substitute in our original equations. So when we substitute in my original equation, like cos square 0 plus sin 0 is equal to 1 plus 0, 1. Cos square pi by 6 plus sin pi by 6 equal to 3 by 4 plus 1 by 2 is equal to 5 by 4. F pi by 2 is equal to cos square pi by 2 plus sin pi by 2 is 0 plus 1. F 5 pi by 6 cos square 5 pi by 6 plus sin 5 pi by 6. So because cos 5 pi by 6 is minus root 3 by 2 value and square is 3 by 4 plus 1 by 4 is 5 pi by 4. And when you substitute value pi, cos square pi plus sin pi gives you minus 1 whole square plus 1. So that is equal to, here it will be 0 because sin pi value will be 0. Then minus 1 square is 1. Ultimately, maximum value will be 5 by 4, that is 1.25, and minimum value is 1. So you just write the absolute maximum value is equal to 5 by 4 is equal to 1.25, and absolute minimum value is equal to 1, that is at 0, pi by 2 and pi. 13th question we already solved in our class. So next is 14th question. 14th question, you have to find the maximum and minimum value of fx. Fx is given sin x plus half cos 2x. So similarly, you have given the interval in your question 0 to pi by 2. X value lies between 0 and pi by 2, and 0 to pi by 2 is also included. So given function is differentiable for all x in 0 to pi by 2. Now differential equation 1 with respect to x. Differentiation of original equation is sin x, differentiation is cos x, and cos 2x by 2 is minus 2 sin 2x by 2. 2 is cancelled, only cos x minus sin 2x is left. So next step is we have to find the x value. For finding the x value, we consider f dash x is equal to 0, cos x minus sin 2x is equal to 0. Now cos x minus 2 sin x cos 2x, here is we apply the formula sin 2x to sin x cos x. Then if we take cos x common, 1 minus 2 sin x is equal to 0. We apply the zero product rule. Cos x is equal to 0, 1 minus 2 sin x is equal to 0. 0 is cos pi by 2, x is equal to pi by 2. Sin x is equal to 1 by 2, that is sin pi by 6. Here we got the two values of x, one is pi by 2 and another is pi by 6. Now pi by 2 already we have given in the interval, so we include only one value. Then our three value for the x is 0, pi by 6 and pi by 2. Now we apply one by one all three values in our original equation. Sin 0 plus half cos 0, sin f pi by 6, sin pi by 6 plus half cos 2 into pi by 6. 2 3s are 6, and then you apply the cos pi by 3 value. Cos 60 degree value is 1 by 2 and sin 30 degree value is 1 by 2. Similarly, pi by 2, sin pi by 2 plus half cos 2 pi by 2. 2 is cancelled, only cos pi is left. So sin pi by 2 value is 1, cos pi value is minus 1. 1 minus 1 by 2 gives me 1 by 2. Here 1 by 2 into 1 by 2, 1 by 4, 1 by 2 plus 1 by 4. When you take the LCM, your calculation will be 3 by 4. So maximum value among this is 3 by 4 and minimum value is 1 by 2. So we write maximum value is 3 by 4 at x is equal to pi by 6, and minimum value is 1 by 2 at x is equal to 0 and pi by 2. Now our 15th question is find the maximum profit that a company can make. You have to find the maximum profit of the company if the profit function is given 41 plus 24x minus 18x k. So here we go with our condition of local maxima and local minima value. So differentiate with respect to x. P dash x is 24x because 41 is constant, that converted to 0. 24 minus 18 into 2 is 32, 36x. So when we find the x value by differentiation term, p dash x is equal to 0. 24 minus 36x, we get the x value 24 by 36. By dividing with 12 each numerator and denominator, we get 2 by 3 because 12 2s are 24 and 12 3s are 36. Now p double dash x, when you go with the double differentiation, we got here minus 36 and here no x value is there. I told you before that if no x variable is there, so whatever sign is there that you have to consider, and whatever point already, whether you substitute or not, so that applies on that double differentiation. Here if it is minus 36, that means less than 0. So what is the condition of if double differentiation is less than 0? That means that is the maximum point. If double differentiation is negative, because he is moving to positive to the negative position, and minimum point means negative to positive position. In that case, we'll check for the double differentiation is positive. Here maximum point is 2 by 3, and find the maximum value, apply 2 by 3 in your original equation. So when we calculate, we got 49. Now is your 16th question. you have to find on the point on the parabola. You have curve is given, y square is equal to 2x. Parabola curve is given to you, which is the closest to the point 1, 4. Any point is lies like a 1 by 4. So from this point to the curve, any point on the curve, you have to find the what are the points on the curve which gives you the shortest distance. So actually whatever you find it here, you have one curve is given like this. So if your y is equal to 2x is there, so maybe your curve is like that. Okay, so any point lies on this curve, and any point lies is 1, 4 is 1 is here, 4 is here, like here, and you have to find the shortest. Any point pxy lies it here, and any point is here. You have to identify that point on the curve, which is that point on the curve which gave the shortest distance from the point a 1, 4. 1, 4 is not lie on the curve. Okay, you have to find the basically you have to find the distance between the curve and that point, and shortest distance. So what will be the point on the curve that gives you shortest distance between a and any point lies on the parabola? So we consider our point on the parabola is pxy and a is 1, 4. Apply the distance formula, x minus 1 whole square plus y minus 4 whole square square root. Our distance formula is distance between the square of the distance between the x coordinates plus square of the distance between the y coordinates and square root. Now if AP is the shortest distance, so if we take the square, that also be the shortest distance. To cancel this square root, we are squaring both sides. Now in place of x, from the curve y square is equal to 2x, we extract the x value, that is y square by 2. We apply it here. Now after solving, here a minus b whole square formula, here a minus b whole square 1, we get the equation in form of y is 1 by 4 y4 minus 32y plus 68. So this we consider as our fy values. Now this is our equation, that is our exact equation which we have to maximum point or minimum point. Now you differentiate this equation, so that gives you 4y cube minus 32, because you have to differentiate with respect to y, because majority of variable is y. So here when you apply f dash y is equal to 0, you get the y value is 2. After getting the y value, you substitute this y value in the double differentiation. If you go with the double differentiation, that gives you 1 by 4 12y square, that is 3y square. And when you apply the value y is equal to 2 here, when you apply the value y is equal to 2, 3 into 4 is equal to 12, that is greater than 0. Greater than 0 shows that if my double differentiation is positive, so that means that is a minimum point. So minimum point y is equal to 2, and another coordinate of x is equal to y square by 2, that is 2, and nearest point that will lies on the curve is 2, 2. Similarly, your second part, second part is also of the same type. Now your curve is y square is equal to 4x. You extract the x value, that is y square by 4. Now let pxy be any point on the curve from the distance, because this is also you have right-handed parabola. A right-handed parabola, any point lies on that curve, your parabola, and you have to find the shortest distance between these 2 points. Any point lies on the plane and any point lies on the curve. What will be the shortest distance from that particular point of curve to the a point? 2 minus 8. First we apply the distance formula here, like x minus 2 whole square, y minus 8, that gives you y plus 8 whole square. After that you have to extract x value from the curve, x is equal to y square by 4. So y square by 4. Now you apply a minus b whole square and a plus b whole square formula. After applying the formula, after calculation, we get the equation y4 plus 16 into 16y plus 64 plus 64 into 16. Instead of calculation, we leave at that point because it will be easier for our further calculation. Here now we differentiate of this equation with respect to y, so we get 4y cube plus 16 into 16. We take 4 common, and my required equation of differentiation is first derivative is 1 by 4 y cube plus 64. When you equal with 0, your y value will be minus 4, because minus 64 is the cube of minus 4. Now y is equal to minus 4. Now you apply this minus 4 value in double differentiation to check what is the sign of double differentiation. That is positive. So that we get 12, that is greater than 0. Greater than 0 show that y is equal to minus 4 is our minimum point on the curve. So finding the x value, x is equal to y square by 4. When you apply y value minus 4 into minus 4, 1 4 is cancelled, x is equal to 4 is right, and your required coordinates will be 4 comma minus 4, that is coordinates lies on the curve. Now 16 question, third part is, now curve is changed. Instead of right-handed parabola, now we have upward parabola. In upward parabola, if any point lies on the plane like 2 comma 4, like here, if this is your upward parabola, like here, this is the shape of upward parabola. So any point lies it here, and any point lying on the plane 2 comma 4, that can be here, here, anywhere, and from that particular point to 2 comma 4, any point on the plane, you have to find the shortest distance and or coordinates. What will be the coordinates of that curve, point on the curve, which gives you shortest distance? If this is the condition, you have to find the shortest distance also. So what you get it here, your this xy value, this is nearest coordinate, you pass it on the your distance formula. You will easily get the what is the distance between the two curves. But here we just have to find the point on the curve. If from particular point A to this point there will be a shortest distance, you no need to find the actual shortest distance. You just have to find the point on the curve which lies on the curve and gives you shortest distance to this point. So we apply again formula here, our distance formula, x minus 2 whole square plus y minus 4 whole square. This time x square plus 8y, we extract the x value, y value, that is x square by 8. So in place of y we replace x square by 8. Now we apply a minus b and a minus b whole square formula. Then after that my required equation will be 1 by 64 x4 minus 4x plus 20. So this is my required equation. Now you have to go with the first derivative. First derivative gives you 4 by 64 x cube minus 4. Then f dash x is equal to 0. 4 by 64 x cube minus 4 is equal to 0. 4 by 64 x cube is equal to 4. X cube is equal to 4 into 64 by 4, give me 64. 64 is the cube of the 4 and x is equal to 4. Now you have to apply this x value in double differentiation. When you go with double differentiation, 12 by 64 x square, that gives you value positive greater than 0, and that means greater than 0 show that that is the minimum point or nearest point to the coordinates a 2 comma 4. Now x is equal to 4. To find the y coordinate, y is equal to x square by 8. You apply the x value here, so that gives you 2, and your nearest point is 4 comma 2. Now your 17th question is there. 17th question, an enemy jet is flying along the curve. One enemy jet plane is flying on the curve. Curve is given, y is equal to x square plus 2. A soldier is placed at a point. Soldier is standing at a particular point a 3 comma 2. Okay, so here you have to find the nearest distance between the soldier and the jet. Soldier, what soldier wants? Soldier want to shoot the enemy jet plane. So if he will be very far from the jet planes, then he will not hit properly the enemy jet plane. So he is thinking about what is the nearest distance between him and the enemy jet plane, so that he can shoot successfully that enemy jet plane. So for that way he has to think what will be the nearest point to him that lies on the curve. Curve is the path of the jet plane. So if my path of the jet plane is y is equal to x square plus 2, so if any point lies on that curve, that is the position of the enemy jet plane on the curve, because he will move on like this curve, and soldier is standing here. He think about that he is continuously moving. At which point he reach the enemy jet plane, he can shoot successfully. So first he has to find the distance. If position of the soldier is at point 3,2 and any point lies on the curve, that is the position of the enemy jet plane. First you apply the distance formula, x minus 3 whole square, y minus 2 whole square. Now you apply the y value x square plus 2 in this distance equation. So we get the equation x4 minus 6x plus 9 plus x square square root. If modulus of EP is the shortest distance, the square of this is also the shortest distance. To remove the square root, we take squaring both sides. x4 minus 6y plus 9 plus x square. Now this is my required equation in form of fx. Now what you do, first you differentiate this one, that gives me 4x square plus 2x minus 6. So before solving this, we have to find the factors of this. So how will find the factor? If I take 2 common here, so what is left it here? That is 2x cube plus x minus 3. So now I have to go with the factors of this. 2x cube plus x minus 3. If this is a odd number, I told you, because here is that is not a quadratic equation, so we can't go with the directly factors to make the factors of that one. So we think about any number which I will substitute here, that gives me 0. So if I start from 1, like 1, 2 plus 1, 3, 3 minus 3 give me 0. So I got the factor 1 is x is equal to 1. That means x is equal to 1 is also factor of this equation. When a 1 shifted on this one, that is x minus 1. Now you divide this equation with x minus 1. We got the quotient 2x square plus 2x plus 3. So that means factor of this equation is 2x minus 1, 2x square plus 2x plus 3. Now after converting to the factors, our next step is f dash x is equal to 0. Now you apply the factors, apply the 0 product rule. X minus 1 is equal to 0, 2x square plus 2x plus 3 is equal to 0. Here we consider x minus 1 is equal to 0 only. We don't consider that one because if you solve that, that gives you irrational number. So that is not possible to apply in the particular point. So we consider only x is equal to 1. Now we go with the double differentiation. Double differentiation of 4x cube plus 2x minus 6 give me 12x square. Double differentiation of 4x cube plus 2x minus 6 give me 12x square plus 2. Okay, now at x is equal to 1, we apply one value, we got 14, that is greater than 0. Positive sign of double differentiation shows that, so whatever x value we substitute here, that is a minimum point. So minimum value you apply in your equation before differentiation of equation, that is x4 plus x square minus 6x plus 9. So y is equal to 5, because actually that is the equation of a distance. So that gives you AP square, because first we consider fx is equal to AP modulus square. So that is equal to 5. So minimum value of the distance, when you take square root on both sides, the square will be cancelled, the EP modulus is equal to root 5. Now nearest distance will be root 5, and now you have to find out what will be the coordinates on the curve, that is the position of the jet plane. So if x is equal to 1 and your path of the plane is x square plus 2, you apply it here. 1 in place of x, 1 plus 2 gives you 3. The coordinates of the jet when it is nearest to the soldier are 1, 3.